Hello everyone, welcome to this KANPUR-NPTEL online course on space environment and its effects on orbital spacecrafts. So, these days we are discussing the different aspects of the neutral space environment, namely the atomic oxygen attack on the spacecraft material. Then we discussed the atmospheric drag force on the spacecraft, which changes the orbital parameters of the spacecraft. Then we have seen the different hypervelocity impacts of the particulate environment, and in the last class we discussed the environment which is induced by the spacecraft itself through various processes, and we discussed another very important topic, that is the scattering of electromagnetic radiation from the particles. As you know, this whole spectrum of almost the whole spectrum of the electromagnetic, that is the radiation, it is used for various types of the observation, whether it is observing the outer space or for the communication. So, for the communication, the RF and the microwave range, even for navigation also these microwave frequencies are used. So, what happens whenever there is the scattering of the electromagnetic radiation from the particles, then it creates, that is, it creates the problem for the true observation of those. It can be optical instruments, it can be a communication receiver. So, this thing we have seen in the last class in detail, and then we discussed about orbital debris. So, we discussed what is the different the types of orbital debris in terms of its sizes and in terms of its origin. So, in today's session we will continue with the orbital debris, and we will discuss today how to deal with this space debris, its management, and in this regard we will discuss what is the international cooperation, because the space is it does not belong to any geographic territory of any country. So, space is common to everybody, it is always global. So, it needs the international cooperation. We will discuss those for the monitoring. Then the monitoring means it is detection and tracking, and for this detection and tracking there are various techniques. So, we will discuss the radar techniques as well as the optical techniques, and subsequent sessions we will discuss how the debris are, after monitoring, how they are captured and how this can be removed. So, this thing we will discuss in the future sessions. So, dealing with debris. So, a space debris object is usually non-cooperative. So, what do we understand by non-cooperative? Basically, these debris of whether it is a part of a spacecraft or it can be the part of the rocket, these does not have any active control system like whatever we have in the active satellite system. It does not have the thrusters, and it does not have any communication system, so that you can send the command to correct its attitude and orbit. So, what does it mean? That because of this non-cooperative nature of this orbital debris, you cannot maneuver or you cannot deorbit intentionally, so that you can bring them in the atmosphere, and when it enters to the atmosphere, it will get burnt automatically by its very high velocity and the friction with the atmospheric particles. So, it becomes very challenging to track and remove this type of debris. So, the greatest challenge is to how to reliably capture and remove a non-cooperative target, avoiding generate even more space debris. So, here it means that if there is some collision, if there is some explosions, instead of one big debris can create a large number of small debris, and small debris are even more challenging, because detecting a very small debris is very challenging, and sometimes it is possible if it is very small. So, the mitigation this consists of a series of made interventions aimed at reducing the risks of a potential accident, or try applying some remedial activities of the impact. So, we will see how this remedial effect, how this the debris can be removed. So, we will see in our subsequent sessions. So, what is that, how you can resolve this problem? So, for that it entails the debris prevention, then the mitigation, or as I said, it needs the remediation measures. The latter means the remediation means it involves the development of the technology to physically remove the debris. We will also discuss those. So, as I said, since it is the space is global, it does not belong to any this territory of any country. So, it needs the collaborative efforts. Especially about the Earth's orbit, because Earth's orbit, it is the man-made satellites are that is getting increased, especially in the low Earth orbit. Because of this, there is the communication like the Starlink, or there are OneWave. There are so many the agencies they are looking for a low Earth orbit communication system, that is a internet network they can provide. So, because of those, so there is ever increasing the number of satellites and subsequently the debris. So, the international cooperation in, so this activity is called the space situational awareness, or in simple form it is SSA. So, it is very vital as Earth's orbit becomes more congested with the satellite and debris. So, basically this space situational awareness, we will see that it is all the space agencies are involved in this activity. So, what this space situational awareness it involves? So, it involves the tracking and managing of the space objects to prevent collisions and ensure the safety of space operations. So, thus this SSA this plays a very critical role in the operation of the interagency space debris coordination. We will see the what is that. An international forum established in 1993 to coordinate efforts among the spacefaring nations in addressing the growing issue of the space debris. So, what is space situational awareness? So, it refers to the comprehensive understanding of the space environment, which encompasses the detection, tracking and analysis of the objects orbiting the Earth. So, we will see what are those. So, these are the satellites, it can be this. So, even the operational satellites, what are the number of satellites, which are the operational satellite, what are the debris. So, all these cataloging can are done by this activity. This is the space situational awareness activity. The natural phenomena like the asteroids or meteoroids or the solar activity. So, even the solar activity means it is related to the space weather. So, the space weather prediction and space weather awareness is also done through this space situational awareness activity. So, SSA it aims to ensure the safety, sustainability and the security of the space operations by providing critical information to prevent collisions and to mitigate the risks and support informed decision making. Now, we will see what is the function of this interagency space debris coordination committee. So, what is the primary purpose of this IADC are to exchange information on space debris research activities between the member space agencies to facilitate the opportunities for cooperation in space debris research, to review the progress in ongoing cooperative activities and to identify debris mitigation options. So, we will see who are the member that is the agencies. So, this include this is the that is Italian Space Agency. Then we are having this CNES, this is the French National Space Agency. Then CNSA, this is the Chinese Space Agency. Then CSA, this Canadian Space Agency. Then DLR, this is the German Aerospace Center. Then ESA, European Space Agency. Then of course, our ISRO, that is Indian Space Research Organization. Then JAXA, JAXA is the Japan Aerospace Exploration Agency. Then CARI, that Korea Aerospace Research Institute. Then NASA. Then it is Roscosmos. So, this is the State Space Corporation of Russia. Then SSAU, this is the State Space Agency of Ukraine. Then UK Space Agency. So, all these agencies are they belong to this IADC, where the debris is that is the where the debris management, debris control and the removal, all these activities are concerned. And this ISRO basically for so this program is called DFSM, the Debris Free Space Missions by 2030. So, we will see for that that ISRO has a program, or it is a, this is called the NETRO. So, this is network for space objects object tracking and analysis. So, this is NE, then we are having T, then TR and then A. So, this is that's why we will see a little bit more about this NETRA program of ISRO and subsequent slide. So, for the space debris management, what are the steps? So, the first step is the detection, then tracking of space debris. So, once it is detected, so the next activity is its capture. So, once you do the capture, then it can this deorbiting mechanism can be done, so that it can be removed. So, we will see what are the ways the reorbiting are done, and the other activities can be the maneuvering spacecraft to avoid debris. Suppose the debris is still there in the orbit, and if this information is known, then this spacecraft or this space shuttle or this ISS, this can be maneuvered, so that the debris, the collision is avoided. The other activity is this is the space debris modeling. So, apart from this, whatever the data available from these various radars and the optical the telescopes, based on those data, there are these simulation activities also, which can predict how the debris are growing and what is the trajectories, what can be the probable the position of the debris. All these things for in order to do all these things, some of the mathematical modeling, or what is called that it is machine learning based. So, these models are made. So, this is also a part of this debris management activities. So, what is the space debris management strategies? So, the space debris modeling. So, this involves the simulation of the positions and how the debris are growing over the time, and what will be the trajectories of the debris, or in what will be its position. All these things can be predicted using the simulation based on the already the huge data available on the based on the measurements by various types of the debris monitoring system. So, this is also very important activities to have a very robust the space debris model. So, what are the space debris management strategies? We will see one by one. So, first one is the space debris monitoring, that already we discussed. So, under that it involves what is the orbit, that is the orbit, its prediction and determination. Then operational collision avoidance, then debris environmental modeling, just we discussed in the last slide, then the debris mitigation techniques, then active removal and the remediation. So, we will see what are those how to remove and the remediation. So, what are the key activities of the space debris management? So, first is the detection and tracking, whatever just we said. So, how this is done? This is done utilizing a global array of sensors, that is the observatories, to continuously monitor the positions and the movements of the space objects. So, we will see how these things are done. Then the next activity is the cataloging and the identifications. So, to maintain an up to date catalog of over 22,000 man-made objects in space, providing detailed information on each object characteristics and the trajectory. Then the other activity is the collision avoidance. So, collision avoidance is only possible when you know where is the position of the debris. So, this is possible by predicting the potential collision between the space objects to enable satellite operators to take preventing measures to avoid the debris impact. Then the other thing is, that is a part of the space, that is the situational awareness activity. This is the space object ownership determinations. So, it ascertain, that is the country which is responsible for the re-entering space object, aiding in accountability and the compliance with the international space laws. So, the set of sensors which are used for the monitoring, that is the detection and tracking, this include the radar systems, optical telescopes, also the passive radio frequency sensors. Okay. So, that we will see what are the the prevention policies, then the monitoring, then capture and removal. Capture and removal, of course, we will discuss in the subsequent sessions. So, the prevention of the onboard breakups, then the removal of mission terminated spacecraft from useful orbit regions, then limiting the objects released during the normal operations. So, the countries with major space programs constantly monitor the space debris using various detection and the tracking technologies. And the space debris detection is more complex than tracking because of the factors like the high object speed and the lack of the brightness. Means since it does not have any other way the normal the radar operates. So, or there is, since there is no communication system. So, what is dependent, that is the scattering of this. If the radar is so this is working in a skin mode. So, for that you need proper the brightness. So, there can be possibility of that the lack of brightness, then its altitude. Higher the altitude, it becomes more and more difficult, and altitude with the even object size also, even in a lower orbit very small size debris it cannot be detected. Then the uncertainty of movement and variety of debris types, because these particles or the debris they are this enormous in number, and their movement and this orbit they are not the defined. So, in that case it becomes the detection itself becomes very difficult. So, debris detection technologies it therefore require very costly high resolution and high sensitivity sensors. So, what are the prevention policies, as just we mentioned in the earlier slide. So, avoid debris generation during the operational life of the satellites. So, this satellites this a contamination free satellite or the other whatever we discussed, that is the its generating in satellite should not generate the debris. Okay. So, this is one. Then during the launch vehicles also there are so many the parts, or there can be the unused the launch vehicle parts in the that is the upper stage of the launch vehicles. So, all these things it need to be avoided during the post mission disposal phase. And next is avoid on orbit collision and breakup of satellites and launch vehicles through necessary failure mode studies, and the redundant systems and mission design with high reliability. So, this gives also you a check on this generation of, that is the debris, means that is the on orbit collisions. So, on orbit collision can be avoided by doing this type of exercises, which gives you a better design and higher reliability. And then this avoid intentional breakups with long lived debris, and the compliance with the post mission disposal, this is called the PMD of the spent orbital stages and satellites with success probability of more than 99%. So, this should be the target, and it should be ensured that either the controlled re-entry or the deorbiting to a lower orbit with less than 5 years remaining orbital life for rocket bodies and spacecraft at their end of operational life. So, we will see that is the different techniques of the space debris monitoring. So, ground based radars, then optical telescopes and laser systems, these are employed to detect and track and to catalog the objects. So, larger than 5 to 10 centimeter in the low earth orbit. So, this can be detected and tracked. Those larger than 0.3 to 1 meter, at greater altitudes, it can be this medium or and the geostationary earth orbits. So, you can see these are the type of observatories. It can be a radar working at the microwave or the radio frequency range, or it can be a laser system, it can be an optical telescope. So, now what is the radar measurement? Just a few basic things I will tell about the radar measurements. Radar measurements are based on the simple principle of echo. So, what is done actually? A signal is sent to a specific target which reflects a part of it and the echo travels back to the source. So, this operation can be undertaken by a single system or by multiple system. So, when it is a single system, both transmissions and the reception are done by the same system or same antenna is used. So, there it is called, it is a monostatic radar system. When two or more systems are involved in this process, this system is defined as bistatic or it can be multistatic when the multiple systems are used. So, generally the transmission signal can be divided into two categories. So, it can be CW radar, continuous signal, or it can be the pulse signal. Now, a continuous signal is employed to retrieve the frequency shift between the carrier and the reflected signal. So, this is because of the Doppler frequency shift. So, this gives you the information about the Doppler frequency and the velocity of the target. And a pulse signal is used to retrieve the distance of the target from the radar, giving the information about the range and position of the target. So, a pulse when it is sent and when it is received back. So, this will give the total the time of both way travel. So, from there knowing the velocity of the electromagnetic signal, the range can be calculated. So, it will be the twice and then divided by 2 will give you the range between the radar and the object. A very useful radar parameter is called the RCS, or it is radar cross section. So, radar cross section, it refers to the equivalent area of the target that is visible to a radar system, which determines the amount of the power scattered back to the radar. It is this RCS it is influenced by the target's geometry, what is the aspect angle, what is the frequency and the polarization, and of course, the physical size also. And the optical techniques. So, this can be detected with optical telescope when the objects are illuminated by the sun, while the sky background is dark. So, for the low earth orbit region, this is only the case during the 1 to 2 hours after the sunset and before the sunrise. And most optical telescopes have a narrow field of view of the order of 1 degree or its less. And the advantage you get using the optical techniques is it is the higher sensitivity, that is the higher resolution can be got. So, even the smaller and smaller particles can be detected. While the radar sensitivity falls off proportional to the distance to the fourth, because here you are sending a signal and receiving it, but in the optical the telescope it is just you are receiving it. So, here it is the sensitivity is a function of distance inversely proportional to the distance squared. So, this is the main reason why optical telescopes are primarily used to investigate the debris environment at high altitudes. Now, I will tell you this is the that SSA activity or this debris the monitoring that ISRO has, that NETRO program, it is called the Network for Space Object Tracking and Analysis. So, this initiative ISRO has taken for enhancing our capabilities in space situational awareness. So, for that there is a radar system. So, it includes the radar facilities capable of detecting objects as small as 10 centimeter up to a range of 15,000 kilometer, then optical telescopes. So, there is an optical telescope has been established as Ladakh to monitor space objects in geostationary orbit, and the projects aligns with the guidelines from United Nations Committee on the peaceful uses of the outer space, that is called the COPUOS, and the Interagency Space Debris Coordination Committee. Already I mentioned about this. And this as a radar, this ISRO is having one, it is called the MOTR, multi object tracking radar. It is an L band means 1 to 2 gigahertz active phased array radar. So, it is designed to track multiple targets. So, it is a long range skin mode tracking radar capable of tracking some 0.25 meter square RCS target up to a range of 1000 kilometer. And amateur can track more than 10 simultaneous targets using single agile beam. So, this is the two photographs. This is the actual, this is the phased array antenna system, which is used for this. The antenna acts both as a transmitting antenna as well as the receiving antenna. It is a very big size antenna, 11.33 meter by 5.66 meter. So, I will end it here, and in the next session we will see what is the different techniques to capture the different size debris. Okay, thank you very much.